welcome to the European Spallation Source, or ESS for short. My name is Anna Godinho. I am Head of Communications and Engagement at ESS. We're here in the main office building of ESS, a multidisciplinary research facility where neutrons will be used to probe the atomic structure and behavior of a wide range of materials, from biological membranes to high-temperature superconductors, from archaeological artifacts to lithium batteries. We're in Lund, southern Sweden, where ESS is being built. Its data management and scientific computing center is located just outside Copenhagen at the Danish Technical University. Sweden and Copenhagen are the host states for ESS, and there are 11 more European countries that are building ESS, with extensive contributions from more than 100 European partners. We will be operational in 2028. ESS will then be one of the world's leading accelerator-based neutron sources and a brand new user facility. Researchers from all around the world will come to ESS to carry out their experiments, whether they be in the life sciences, in environmental sciences, in particle physics, in sustainability and energy. To tell us more about ESS today and where we're going, we have with us Helmut Schober, Director General of ESS, and Robert McGreevy, Chair of the ESS Council. Thank you very much, Helmut and Robert, for being with us today.
Thank you, Anna.
And I would start with Robert, a question for you, maybe.
Yeah.
You've been chair of the council since 2023, but you know ESS very well. You've been involved in the project right from the start. So in your view, where does ESS sit within the family of neutron sources that exist in Europe and around the world?
Okay, I'll put this in a slight historical context because it's relevant. And you mentioned the fact that the ESS was an accelerator-based neutron source. The neutron scattering started in the 1940s with the development of nuclear reactors and the realization you could use the neutrons to study materials. And they had a real boom in the 1960s and 70s because all over the world people were building research reactors to support nuclear power programs. After a while it became realized that building more powerful reactors to do research, we sort of got to the limit with the Institute La Langevin in Grenoble, where Helmut used to be director, or the spallation neutron, the high flux isotope reactor in the US, and they were built in the 60s and 70s. So technically, we reached the limit really with reactor sources, and so from the 1970s and 80s, people started developing accelerator-based sources with the potential to go further. But it was also realized that because you had this boom in reactor sources, that at some point when they started closing down, you would have a sort of bust and the economy goes down. And so you would need to be building new sources because these take a long time to build. You have to have a long time planning horizon. So ESS, it was recommended that the three major regions in the world, that is the US, the Oceania, and Europe, would each build a major neutron source based on accelerators. In the US, you had the spallation neutron source. In Japan, you had the J-Park facility. And ESS is the third of those. And so that's where it fits in that context. And of course, because it's the one that's slightly later, it can build on all the technical advances we've had from the previous facilities and go slightly further. So that's where it fits in the historical context. And unfortunately, over the last decade or so, the closure of facilities in Europe particularly has come to pass. So, for example, we lost 3 facilities in 2019. And so ESS is really needed both to provide this new capability, but also to provide some of that capacity for researchers to do research. So the way I would phrase it is that ESS is expected to be what you call the flagship facility in Europe, but it's actually also going to have to be a bit of a container ship as well, because it's going to have to support a wide range of research from the really most complicated to actually some relatively standard research.
Yeah, it's very interesting. And you mentioned flagship in Europe,
Yeah.
and I just wanted to come to you, Helmut, on that, because it really is, and it's been even by the European Commission proclaimed or mentioned as a flagship in their strategy for research infrastructures. So where do you see ESS or its role in the European research agenda and the position of Europe in science and in the world?
Well, I would start from what we do with a source like ESS, right? And it's the same for the synchrotron sources like MAX4 next door is study materials and processes. And even so, we have made tremendous progress in understanding materials and processes. And I think the latest revolution in that was really coming from the digital world with using, for example, artificial intelligence in the context of material science. There is a truth that remains, and the truth is that you need experimental information to test your understanding, to test your simulations. And we have developed over the last decades an enormous toolbox to investigate materials. And you have the X-rays, right, as I just mentioned, the synchrotron sources, but you have NMR, you have cryo-EM, and part of that toolbox is neutrons. And we have a privilege in Europe that when it comes to this part of the toolbox to study materials and processes, we have been world leading for the last 50 years. And that leadership is grounded on one side in the facilities we have, and Robert has alluded to some of them, right? The ISIS facility, which pioneered this pulsed spallation sources in Europe, the PSI with the continuous spallation source, our flagship, the current flagship in Grenoble, the Munich reactor, and then smaller sources. But also that we connect that to a network of researchers at the universities, in the industrial laboratories, depending how you count, between 6,000 and 12,000 researchers that use us. But the world is moving on. All these techniques improve, and now I come back to what Robert has said. The potential of the spallation sources has not been completely exhausted, and our role is to provide to this European network a top-of-the-range spallation flagship. And that is what we have to do here at the ESS. And what will society get back? I mean, we have our ESS ways, as you know. We have identified, I think, 4 main fundamentals where we want to create our impact. One is to continue to have absolute breakthroughs in fundamental questions of science, and they can come, for example, in quantum physics, but also in the life sciences. Fundamental physics, if one day we should have a beamline in this direction. But then naturally also everything that is related to economic competitiveness, the industrial processes, and that brings us to those topics that everybody is concerned about, like the energy transition, an aging society with its health problems that come along, the climate change. And in all those areas, we try to help find solutions to very practical problems. And then something that lately has gained more importance is what you call sovereignty. And there it's not only that in Europe we have those sources and we are not depending on other continents to exploit those scientific questions, but also that we have the technology in Europe, and we are not depending on other continents for building something like the ESS. And when it comes to our accelerator, you go out there, this is really top of the range, right? In terms of our cryo modules, the way we power it with the RF. The target is absolutely innovative. That bears its risks with it, but that's where a lot of the performance gains come from. So we also want to make sure that, through the ESS, we keep the technology, again, in this network. And it's not only the neutron centers in this sense, it's also the other accelerator sources. And I know that you worked before at CERN, and a lot of collaboration is going on with CERN, and we will try to profit from that in the future, same with ISIS. And then naturally the 4th pillar is something that we take it now nearly for granted, sustainability. But also there we want to be a role model when it comes to use energy in the most effective way, so that we don't create our own footprint on the climate. So I would say this is what society can expect from us. A real world-class facility that helps them radiating in science, protecting economic competitiveness, and sovereignty.
Mm-hmm. And you mentioned building ESS, and in 2014, where we are now, was a
Greenfield.
greenfield.
Yes.
And now we have not only this beautiful building, but especially the machine, the accelerator, target, the instruments are coming along, the integrated control systems. So just tell us a few achievements over these past years, and maybe more focused a little bit on last year, 2025, but in general, what have we achieved?
Yeah, I think we should underline what you just have said, right? In 2014, this was a field, I think it had a pole where you have now the center of the target. And today we have all the buildings completed, and when in 2022 those buildings, while in 2022 those buildings were empty, today they are filled with all the equipment. We have basically installed all the equipment necessary for the accelerator, and then for the target, and a big number of instruments are also at the stage where they are not far from being able to receive neutrons and do first science. And last year was particularly important because if you think in the typical project management phases, right, where you go from design to then construction and then to commissioning and operations, we are depending on where you look at the facility, have finished the installation and now going into commissioning and for some parts into operations. That was the most pronounced for the accelerator, where we had what we called the beam on dump milestone. So at the end, we want to direct the protons that we accelerate in the accelerator towards our target. But we have also what we call a beam dump, and it can take, with our current license, up to 12.5 kilowatts of power. So we use that to make sure that the accelerator works as foreseen. And one of the parameters that is very important is that we can provide the protons with the energy of more than 800 million electron volt. And that we could test in April, May last year. That was a very important milestone for us. In parallel to that, we worked really heavily on the license, and I think another milestone we had last year was the submission of all the material of our license application for what we call the license for intentional neutron production. And we are still waiting for the feedback from our regulator, SSM. And more generally, people worked very hard in building up competence, for example, in the main control room, right? And do all what we call systems acceptance reviews, tests, to make sure that not only the equipment is here, the IT infrastructure is built up, but that we also know day by day how we have to behave, what we are allowed to do, what we are not allowed to do, how we regulate access, how we deal with certain situations like emergencies. And if you do build that on a green site, I think we can be extremely proud of what we have achieved over the last now 11 years that the ERIC exists, right?
So, Robert, I would ask you, in Council, how does Council see, how do our member states see the progress that's happened at ESS?
So those of us who can remember popular music from the 1970s will know that the road is long. And the road to building a facility like this it's a long road. It requires a lot of work. But as you've already alluded to, this was a greenfield site. Most facilities of this type have been built on existing laboratory infrastructure, and so have a lot of advantages. So that's an amazing achievement in itself to do that. And I remember, the original years of construction is the buildings, it's the civil construction, etc. That's mostly done by external company. It's still impressive, but nevertheless is not the science bit. Then, unfortunately, we had the pandemic, and so those of us external couldn't come and see what was happening. We come back 2 years later for the first meetings, and you could already then start to see the accelerator construction, the scientific coming. And since then, the progress has been really visible and remarkable that the accelerator is now operational, has been said. The instruments which will produce the science, you can see, every time you go out in the instrument hall, there's more development, etc., etc. So I think it's important for council. We talk about the road to science. Now we can see the science at the end of that road. It's not just saying we're on the road. It's saying we see the end of the road and we're getting there. That's really important for council. But the other important thing for council then is the delivery of that science is around transitioning from building something to running it. And that's a big transition, and that's important to get through. And so that's one of the big things that council now wants to see, is not that we can see where to get to, but see when we get there, we can actually work in that new environment.
Okay. And so do you think, I think this is a question for both of you, do you think in that regard that 2026 is all years are important, but if you think of what does council have to discuss or decide on in 2026? What will ESS be focusing on this year in 26?
Well, I think, I know what council has to.
Well, shall I say that?
Yeah, but go ahead, Robert.
Okay. What is ESS is a big investment to construct ESS. A big investment is billions of euros. To operate ESS is a bigger investment, right? That although we might think about, okay, it only costs so much to operate each year, you are asking countries now to operate ESS for 40 or 50 years. Mm-hmm. So you're asking them to commit to an investment over that period of maybe 8 to 10 billion euros, right? That's a massive investment. It's a serious thing. It takes a lot of discussion, a lot of agreement between countries. We are actually going to do that thing. So that is certainly the biggest thing we have to do in 2026, is finalize that agreement for the long-term construction. But as I said, then we want to be sure that when we make that investment, that the facility is going to operate for this user program that you've talked about and deliver for the science. And so that not only, if you like, the money is provided, but the organization changes itself in such a way that it can usefully use that money and make a good return on that investment we're making. Mm-hmm. So those are the two big things for 26.
All right. Helmut.
Yeah, from my side, it's just, as I said, we are in this phase, commissioning and going towards operations. So those who are here at the ESS, they know that we talk a lot about steady state operations and the transition into steady state operations. This is a major endeavor. When I started this job, I had been interviewed and said, well, how do you imagine this transition? And I had in mind these transformers, right? Where you have a truck, and after a bit of time, the truck becomes a robot, android. And this is a little bit what we have to do, right?
Would it be that easy?
Yeah, so that is a big challenge because it involves organization, it involves people, and we have to do that while we are finishing the project. So everything we do must not disrupt the ongoing work, and I think we're on a good way here. We have put in place certain structures and we work diligently at that. So this, I think, is one thing that is very important for us in 26. Then, as you also may know, at the end of 25, we had a little bit of a setback with one of our technical equipments. And we have to make sure that we replan the project in such a way that while we wait for a replacement of that equipment, we use basically every hour in the best possible way to move forward. One way to do that is, for example, for the accelerator, which is not concerned by this setback, to forge ahead and to do another commissioning run and to test now not only the final energy that we achieve, but other beam parameters like the repetition rate, the pulse lengths, ramping up the current. For the instruments, full steam ahead. There is no reason to delay anything. At the moment, several instruments, as I said, are ready to receive neutrons. Next year, we hope they will be at the number of 7 or 8, and then in 28 we want to start the user program. So That's also very important. And the work on the operational readiness, which building up the competence internally, that also must forge ahead. So we will certainly in 26 not be bored in any way. It will be like all the other years, a very exciting year. You know, Robert mentioned that building such a facility is like walking a path, a journey. As you know, I come from the Alps, and the way I see it, yes, you want to reach that mountain top, and this is the aim that we have, and you have a very clear plan which path you take, and then you come around the corner, and all of a sudden you realize there was a little landslide. And then you have to find an alternative route. And I think this is for a complex equipment like the ESS, this is what you have to do every now and then, and your capacity to deal with that situation is part of your competence. We should never forget, nobody has ever built a facility like that, right? It's not like building another, not to say anything bad about IKEA, but if you build another IKEA shop, right, it resembles very much the one you had already. That's not the case here, as we have to push the performance of our facility. This is mainly done in the via the target. We have to go to very innovative solutions there. So we're chuckling permanently with this tension of trying to build resilience, reduce the industrial risk, and push performance. Yeah, and for that we need risk management. Yeah, that will be, I think, the next year. Very exciting. And not to forget, as Robert has said, the users will come in 28, and the users, they expect a lot. I think they will be comprehensive, our first users, but they have the choice, and they are used to very good service from other facilities. So when it comes to the holistic service, can I treat my data? Are the labs working? Is it easy to get quickly chemicals that I need because something has changed during the experiment? We will be charged on that, and parts of the organization are working on that. We're hiring quite a number of scientists to build up this part of the organization. So I think in general, right, it's very exciting times, but also very demanding times that we are confronted with.
Well, as someone who's recently joined ESS, I have to say that it is a truly exciting time for communications to be here. As you were saying, Robert, it's almost, we can see the end of the road. It's becoming clearer, and it is super exciting. And also the resilience and the team spirit at ESS is quite impressive. And I'll come back to you on the users and where you see, I'm going to ask you if you can paint a picture for us of ESS when it's a user facility. But on the topic of users, and I know that for you, Robert, ESS being an effective or the best user facility is very important, and that also underpins Europe's success in neutron sciences. So again, from the council perspective, how do member states see ESS when it is a user facility? How can it support its communities, its the national communities? Is there a role for ESS in that?
Well, absolutely. I mean, as you know, I'm quite keen on the concept of user facilities, and I think particularly in Europe, I mean, we are good at neutron scattering. We have been, I hate the words being world leading, but actually Europe has been world leading in neutron scattering since pretty much the beginning. Not quite exactly, and that is because we realized really early on that you cannot utilize the capability of such a facility just by having your in-house researchers use it. It's just much more powerful. And so you develop user facilities where, yes, your in-house researchers might use 20% of the time that's available, but external researchers use 80% of the time. And you build these enormous communities which then go on for years and years, and they have students and postdocs, and they also become users, etc. And we've been doing this in Europe for a long time, and we're very good at it. So this is why countries want to join is they don't want to join just because there'll be some researchers in Sweden doing some research on this. They want to join because their researchers will come here and they will use it and they will spread out, etc. So that's the value of this central thing. I think it's really important, again, just to understand when the first user comes through the door downstairs, right, this place will change. Because it will go from being that place where people are just working for themselves, where now that person who comes through the door is the important person they have to deal with. And I would also say, from the point of view of being a success, I mean, the council wants ESS to be a great success. Being a great success is not just having a hole in the wall down there where lots of neutrons come out of the hole in the wall, however reliable, etc. that is. The success is people will come here to work with people. Right? They don't come here to work with the machine. They expect the machine to be here. They expect the machine to work reliably. They come here to work with other people, the expert scientists here, the technical teams who support them, etc. It's a team activity. And recognizing that it's a people-to-people interaction that makes the success, not a people-to-machine, is what we want to see from ESS, because that will be the success.
Okay, Helmut, would you like to add to that?
No, I think, you asked me what would the user experience be, and I think, again, I would decline it a little bit along the journey. For our first users, what is important is that, as Robert has said, their experience is such that they can go home and say, well, I got something out of that, right? It helps me progress with my research. Ideally, when they go back to their university and meet somebody at the coffee, they would say, I've been in Lund. It's really great service. I met great people. I recommend you also write a proposal and go there so that we get this dynamics. But we should be humble in the beginning, because we will still be in ramp up and commissioning. And we know from experience that these complex machines, in terms of reliability, they need a little bit of time to reach that. And so in terms of managing expectations, I think this is very important that we do that. And hopefully we reach that level of reliability early on for our pioneering users so that they become these great ambassadors. And then I see it, like really speeding up, revving up a machine, like you would rev up a motorbike in a GP race. So we will, over the years, make sure our instruments are fully scoped, that so we can deliver the full performance. The reliability I had already mentioned will go up, but also the power of the accelerator will go up. We will have new instruments in the pipeline. In particular, we will have hired those scientists, because this is also, I agree with Roberts, people want to work with people. And so this becomes a scientific powerhouse, right? Our own scientists with the users, and then we radiate because we have success, and because we radiate success, the council will be happy to give us more money for a more extensive development program. And then and in this dynamics, we become a beehive. We are recognized internationally as the new kid on the block, but also now the mature kid on the block and the leading kid on the block. So that's a little bit what I'm looking for. And at the end of the day, we will be judged by the impact that we leave outside our own field. It must be the biologists that are not using themselves neutrons since decades, or the people in energy materials. They must realize that what we contribute to them is really added value, and I come back because it's a breakthrough understanding in fundamental question, or it adds to our competitiveness economically. And then we are in a virtuous circle where we just have to make sure that we don't rev completely out of the orbit, right? So, but this is the way I see. Start humble, and always convinced by what you deliver, right?
Okay.
Yeah.
Sounds like a good plan, very promising. There is so much more that we could talk about. We do have to wrap up, so I would ask if each of you could if there was one message you could leave, either to the future users, to staff at ESS now, to the general public, to our decision makers, what would that be? I think maybe Robert, let you go first.
So I was thinking about this, and for some reason, what popped into my head was it was a British political thing from some years ago, where there was a political party approaching an election that was very confident that it could get elected, and the leader of that political party told his people, he said, "Go home and prepare for government." They didn't get elected, but that wasn't successful. But nevertheless, it's the message. ESS has to tell its staff, go home and prepare for operation. Because, to be honest, operation is probably like being in government. But, it sounds very easy and everything once you're outside of it. Once you're in it, you realize, oh, okay, now we can make a difference. That's where you get the return on the investment we were talking about earlier. But it's hard work, right? And you have to keep doing it. And we're talking about the road. The road is then uphill. It may be slightly, only slightly uphill, but for the next 40 years, it's uphill, and you've got to keep on going.
Should be uphill.
But that's where you make the difference.
Okay, very good. Helmut.
Well, I will go a little bit in the philosophical domain. Let's become enthusiastic again, and let's make sure that with this enthusiasm, we build a bright future for our children to have even more opportunities than we have already. And because we have so many things that we value in Europe, and that absolute merit to be defended. And I think what we need is a couple of projects that make us dream. And if we do the ESS right, ESS can be, like maybe the Airbus when we launched it at some point. It's a big comparison, but at a smaller scale, something that really can help us, a cause that we should rally around and make us believe in our own future and push forward.
Okay. Well, I think those are two very good messages to end on. Thank you very much, Helmut, Robert, for giving your time. I know you're extremely busy, especially this week. So thank you very much. And thank you for joining us for this over these 20 minutes or so. And if you would like to ask any more questions or leave any comments once this video is published, please feel free to do so. Thank you.
Thank you, Anna.
Thank you.
Thank you.